Hi guys, I just decided to record what we had talked about yesterday at my Google Meets. Um, Quadratic functions. So first thing, a quadratic function is a function that can be written in standard form. Remember, standard form is where you have y equals, and then you have that x squared term, x term, and then a constant on its own. Or you can have it in function notation where it would be f of x equals your x squared term plus or minus your x term plus or minus your constant. A cannot equal 0 because if a was 0, then you would no longer have an x squared term, and that would make it a linear equation. All right, so a couple things that you're going to want to be able to pull out throughout talking about graphic functions or graphic equations is the A value, B value, and C value. The A value is always going to be the coefficient of the x squared term. All right, so you're looking at A, x squared. Your A value is going to be what's in front of the x squared term. So you're looking for, when you have that exponent of 2, look for the coefficient. All right, the B value is always going to be the coefficient of the x term, or if you were to have a to the first, which most of us don't write that little number 1 there. So if you just had an x by itself, whatever the coefficient is, that is going to be your B term. And then C is the coefficient of the constant. And that's really like saying c to the x to the 0 power, but we don't ever really see this written as x to the 0 power. Remember, x to the 0 power is the same thing as 1. 1 times c would just give you c. So whenever you see a number by itself, that's a constant, okay? So it's the coefficient of when you have x to the 0 power. All right, the equation for the parent function is y equals x squared, or if we wrote it in function notation, f of x equals x squared. All right, so before we get into talking about the different parts of a quadratic function, I do want to look at the graph of what y to the x, or y equals x squared would look like, okay? So what I'm going to do is I'm going to put this in my calculator. I'm going to pop in x squared, enter, and the easiest way for me to graph this is to look at my table of values. Second table. Okay, there we go. All right, when I look at my table right now, it starts at 0, and it goes, my y values go 0, 1, 2, 4, 9, 16, and it looks like it just keeps kind of curving up like this. Well, I want to see both sides of this quadratic, okay? When you're looking at a quadratic, and I'll talk about that a little bit over here, quadratic is always going to make a U or a curve. It's going to go up or it's going to go down, okay? So looking at the values I have here, I only see one side of my curve, so I'm just going to go into some of my negatives. Just like when we are driving, or when we are graphing linear equations in the 7th grade, you always use some negative numbers and some positive numbers. So in this case, let's do -3, -2, -1, 0, 1, 2, and 3. All right. So when x is -3, -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 is 0, 1 is 1, 2 is squared is 4, and 3 is squared is 9. So I'm going to plot those points. So I got 0, 0. I have +1, +1. I also have -1, -1. I have 2, 4, and I have -2, 4. And then I have 3, 9, and I have negative 3, 9. And notice that they don't make straight lines. They make this curve that's going to go up and out. It's going to go up and out. And then I have a curve. Oh, I don't like how I'm drawing that. I have a curve that's going to go up and out along the other side. Okay. And I'm going to label this y equals x squared. All right, let's go back over here and look at some different parts of this quadratic. All right, if the graph of a quadratic, one thing you want to know about the graph of a quadratic is we always call it a parabola. Uh-oh. Okay, the graph of your quadratic is called a parabola. And like I said, it's going to be a shape that where it's a curve that goes down, or it's going to be a curve that goes up. And two things that are going to indicate which way it goes is if that a value, the number in front of that x squared term, if it's positive, then the parabola is always going to curve up. It's going to open up. Okay? If that a value is less than 0, or if it's a negative value, then it's always going to open down. So this is considered down. This is considered opening up. Okay? All right, the next couple of points that you want to be able to recognize on your parabola are the lowest and the highest points on the parabola. So you're going to see that there are always these curves, okay? So when the curve comes down, it reaches, in this case, a low point. All right, this low point is then that turning point where then it starts to go back up. Okay, that point, that turning point, we call the vertex. Okay, this is also known as the parabolas, in this case, in our x squared situation. It comes down, and this is the lowest point in the graph, okay? That's the smallest y value that you actually encounter. So that would be the minimum value for this graph. If you had a curve that went up and it came back down like this, we know the vertex is here, around here, because that's the turning point. But that's also the highest point of the graph. There's no points above that. So that's going to be the maximum value. Okay, so the vertex for the parent function, so if we look over here, the vertex for the parent function actually ends up being the point 0, 0. Okay. Another important thing that you are going to want to be able to pull out from your graphs, or even be able to pull out from just the equation before you go to graph it, is the axis of symmetry. Or sometimes you're going to see it as AOX, axis of symmetry. Okay, what that is the vertical line that goes through the vertex, and it's going to split your parabola in half, okay? I think you guys are pretty familiar with axis of symmetry from the last couple years, and even in elementary school. Symmetry means that you can take a line and you can draw it right through the middle of the shape, and it's going to split it in half. So if I were to fold this piece of paper, imagining if it was a piece of paper, if I were to fold this piece of paper along that orange line, everything on this side is going to fall directly on itself on the opposite side. So that would be your axis of symmetry. Okay, so that's an important piece of our parabola. In order to find that axis of symmetry, you have to remember back to when we were graphing. Lines, vertical lines were always x equals a number, and this is going through the x coordinate of 0. So this particular parabola has an axis of symmetry of x equals 0. And in a little bit, I'm going to show you how to use a formula to find that axis of symmetry. Okay, points where the parabola crosses or touches the x-axis. Where they touch across the x-axis, these are called the roots, zeros, or x-intercepts. Now, we already talked about these, but we talked about them when we were solving quadratics algebraically. When we were setting our quadratic equations equal to 0, we were saying that y equals 0. Well, when y equals 0, that technically is the x-axis. So what we were doing is we were setting that quadratic, and we wanted to know, okay, well, what are the x values when y is 0? Well, what are the x values when you cross the x-axis? So that is what the roots, the zeros, and the x-intercepts are. If we look at our parent quadratic, this one is only crossing that x-axis at one point. So this particular problem, there is only one root, and that root is 0. Okay? You are going to see different situations. You're going to see where you have two roots. So that would be an example like if this is your x and y axis, if you had a parabola that came up and down, if it crosses the x-axis at 2 points, that's going to have two roots. There's other examples that if you had your x and y axis and you had a curve that went like this, well, this is not touching the x and y axis. It's not crossing the the x-axis. So there will be no roots. This wouldn't be possible to find the roots. Okay? All right, so over here, just looking at our quadratic function of x squared, we're just going to pull out and show the relationship between the different pieces that we are pulling out from this equation. So what would our a value be? What is the coefficient in front of the x squared term? 1. What is the b value? Well, this technically is saying, again, y equals x squared plus 0x, because I see 0 x's, plus 0. So my b value is the coefficient of that x term, so it would be 0. My c value is that constant, so that would be 0. My x-intercept, well, where is it crossing the x-axis? That is crossing at 0. The y-intercept, okay, this time the y-intercept is going up and down, so where's that going to cross the y-axis? 0. What's the minimum value? So the minimum value in this case is it's coming down and it's crossing right here on our graph. So the minimum value is 0. And when you're talking about your minimum value, you really only have to list the y value. The vertex is, well, where is that curving and going back up? And again, that's at this point. So that vertex would be 0, 0. And the axis of symmetry, where's that line that's cutting right through the middle of the graph? And in this case, it is x equals 0. And remember, axis of symmetry is always that vertical line that cuts through the vertex. Okay?